The United States military budget for the fiscal year 2023 stood at a staggering $820 billion, encompassing various categories such as personnel costs, operation and maintenance, procurement of new weapons and systems, and research and development. Imagine if a fraction of this budget was allocated to science projects. A closer examination of specific military programs and their scientific counterparts reveals a stark contrast in funding priorities. For example, the F-35 fighter jet program, with an estimated lifetime cost of $2 trillion, could have funded over 225 Large Hadron Colliders, the world's largest and most powerful particle accelerator. Similarly, the cost of a single Gerald R. Ford-class aircraft carrier, a staggering $14.11 billion, could have fully financed the James Webb Space Telescope, a revolutionary instrument poised to unveil the mysteries of the cosmos. Nearly 1.4 times the annual U.S. nuclear weapons budget, approximately $46.89 billion, could have entirely funded the International Thermonuclear Experimental Reactor project more than twice over. This project is aimed at harnessing nuclear fusion as a clean and virtually limitless energy source, and it represents a potential solution to the global energy crisis. Meanwhile, the Zumwalt-class destroyer program, costing $23.87 billion for 3 ships, could have funded the Human Genome Project nearly 6.5 times. This groundbreaking project, which mapped the entire human genetic code, has revolutionized medicine and biology, leading to advancements in disease diagnosis, treatment, and prevention. The entire Human Genome Project cost about $2.7 billion over 13 years, equivalent to roughly $3.71 billion in 2024, less than 1% of the current annual military budget. Similarly, the Curiosity Mars rover mission, which has greatly expanded our knowledge of Mars and the potential for extraterrestrial life, cost approximately $2.5 billion in 2012, about $3.44 billion in today's dollars. The B-21 Raider stealth bomber program, estimated at $203 billion over 30 years, could alternatively fund nearly 29 Mars sample return missions, significantly accelerating our understanding of Mars's history and potential habitability. And here is another striking example. 4 years of the military space budget, amounting to $25.99 billion annually, could almost entirely fund NASA's Artemis program, an ambitious endeavor to return humans to the moon and establish a sustainable lunar presence. Moreover, the F-22 Raptor program, budgeted at $66.7 billion, could fund about 172 Ocean Observatory's initiative-scale projects, dramatically improving our understanding of ocean processes and climate change. The Global Hawk drone program, costing over $10.61 billion since 2001, could have funded nearly 5 square-kilometer array-scale radio astronomy projects, potentially leading to breakthroughs in our understanding of the early universe, dark energy, and cosmic magnetism. The stark contrast between military expenditures and the relatively modest costs of scientific breakthroughs and humanitarian initiatives is further illustrated by examples such as the Global Polio Eradication Initiative, which has reduced polio cases by 99.9% since 1988 at a cost of roughly $35.01 billion in today's dollars. Even more ambitious goals, such as ending world hunger, which some organizations suggest could be achieved with an annual investment of $330 billion, could theoretically be funded by reallocating a portion of global military spending. It's worth considering how such investments might contribute to solving pressing issues like climate change, energy production, and disease prevention, potentially creating